All right, we are now going to talk about growth rates of Leslie matrices. So it's these notes here, but before we dive into the notes, we're just going to go through this example here. So let's read the example and see if we can make some sense of it. It says, for the following initial state matrix S of 0, the Leslie matrix L, find the long-term growth rate correct to 2 decimal places and the percentage increase or decrease. What exactly is the long-term growth rate? Well, what it means is that in the long term, is our population increasing or decreasing by a certain percentage? So it might be that in the long term, this thing is increasing by 10% each year, or it might be decreasing by 3% each year. Whatever it may be, this is the long-term growth rate. How much it's increasing by each cycle. Each cycle, how much is it increasing by? And that's what we want to find out here. How much is it increasing by each cycle? So let's see if we can figure that out. To do this, what we need to do, just as when we were finding steady state, what we did is we raised it to the 50. Well, when you're finding long-term growth rate, it's not exactly the same as steady state, because remember, steady state is when everything kind of remained the same. Things aren't remaining the same here. They're increasing still, or they're decreasing still, but the percentage by which it's increasing or decreasing is remaining constant. And that's what we're finding. You know, is it increasing by 10% each year? Is it decreasing by 7% each year? What we want to do, as we do for steady state, is we're going to do this. We're going to go S of 50 is going to be equal to Leslie 50 times S of 0. And we're going to see what that equals. And then once we've done that, we want to find S of 51 and go Leslie 50 times 51 times S of 0. So that's what you want to do, just as we normally do for steady state. Once we have done that, I've already put this in here, so I just want to raise this thing to the 50th power. There is my answer. Now, I am going to write this out. So it's going to give me a second as we write this out. I think it's important for us to do it, because then you can have really nice notes here. So the few of us who were away when we did this in class, we did write this out. And people were thinking, why on earth are we spending all this time writing down all these numbers? But I think it's good to have in your notes, just so you know what's happening. Otherwise, when you're going back later, it's confusing. Da-da. Then we do it again. So I take this, booped, 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 minus, put a 1 there. So now it's 51. This is exhilarating stuff. Hopefully you're not finding this too crazy. 7, 4. All right. All right, once we have now done that, I might just divide up our page here. What you now want to do is you want to find your long-term growth rate. So I'm going to write down long-term growth rate. And the way that we find, our long-term growth rate is we go S of 51 divided by S of 50. But you're not going to divide like this whole thing by that whole thing. You can't do that. You can't divide a matrix by a matrix. Rather, what it is that you're going to do is you're just going to look at the same element. So in this case, I'll look at the element 1, 1, meaning, and I'll highlight this so it makes sense. If I just choose another color here, I'm going to take this and divide it by this, and actually the other way around. So the S51 divided by the other one, S of 50. So I'm going to take this number right here. Let me come here. Let me write it down. I'm going to take 4394592.80, and I'm going to divide it by this number here, 3747748.62. Hopefully I wrote down those numbers correctly. And now, it doesn't even matter, because what I'm going to do now is I'm going to say, take this number, and remember, use your keys wisely. If you come here, and now you hold down the shift button, and you go across, it will highlight the whole thing for you. And then you can just bring it down. Divide. So don't actually type it out. Bring up your cursor here, hold down that shift button, and then go across. I can't do it because I'm on the computer and it doesn't let you, but you can do it on the handheld. And we're going to end up with 1.17. ... And then you're going to do the same thing. So I'm going to go S of 51 over S of 50. But instead of now doing our first element, let us now do our second element. So second row, first column still. And I'm now, before I did the blue numbers, now I'm going to do the pink numbers. And remember, you first take your bigger one. So I'm going to go 749,549.72 dot 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 over this number 639,170.44 dot dot dot. All right, and now I'm going to divide those two things. I didn't like that highlighting there. Whoop, let's try again. There we go. And again, don't type them out. Make sure you just do that. Whoa, whoa. Think. Look at that. You get the same number out. And that's what you need to see. You need to see that you get the same number out. If you don't get the same number out, what you should do is you should like raise by a higher number. So instead of 50 and 51, maybe you do 100 and 101, whatever that may be, until you get that same number out. But now looking at this, we can therefore comment on it, and we can say, we can interpret it, and we can say, therefore, the long-term growth rate is 17% increase. So if with each cycle that goes by, we're increasing by 17%. And that's what's happening. If we now come up here and we read through our notes, this makes sense. So let's get our yellow highlighter out and let's read through these notes. Just like a regular transition matrix, let me see if I can read. Just like regular transition matrices, which reach a steady state, we often see populations reach a proportional equilibrium. While the numbers do generally continue changing, the proportion of the population in each aim group stabilizes. We call this the long-term growth rate. For two-state matrices with large consecutive values of n, if each of the elements in S of n plus 1 matching elements in S of n. So this is simply saying, we took an element from S of 51 and then we divided it by that same element in S of 50. And what you get out is the value G, and that is your long-term growth rate. G is the long-term growth rate of the population each time period. So G is the long-term growth rate of the population each time period. So with each time period that goes by, you're increasing by 17% in this example. This is how you interpret it. It's exactly the same way that we've done things in RFM, so hopefully that does make sense. If the number is greater than 1, it means the population is increasing. If it's less than 1, it's decreasing. And if it's 1 exactly, it means that the population is stable. All right, that's everything, people. In terms of this page right here, remember, this is important stuff. You can practice these skills if you so choose in your Cambridge, or you're just going to make sure that you have a really good understanding of this page right here. Remember, Leslie matrices aren't on your practice sacks, so you need to make sure that you're revising them independently, either using Edrolo or your Cambridge. So just make sure that you are revising properly. And looking at your notes as well, making sure your notes are good, and hopefully this has helped those people who are away when we went through this stuff here. Alrighty, bye-bye.